Hello students. In this video, let's start with Unit 4. The first topic is code optimization. So what is optimization? Optimization is the process of transforming a piece of code to make it more efficient either in terms of time or space without changing its output or side effects. The only difference visible to the code's user should be that it runs faster and it consumes less memory. Optimization is classified into two types. The first one is machine independent optimization and the second one is machine dependent optimization. When we talk about machine independent optimization, it is program transformation that improve the target code without taking into consideration any properties of target machine. Machine dependent optimizations are based on register allocation and utilization of special machine instruction sequences. Some of the code improvement transformations are as follows. The best program transformations are those that yield the most benefit for the least effort. Any transformations made on the program must preserve the meaning of programs. That is, the optimization must not change the output produced by a program for a given input or cause an error that was not present in the original source program. A transformation must, on the average, speed up the programs by a measurable amount. And the last one is the transformation must be worth the effort. Some of the principal sources of optimizations are common sub-expression elimination, copy propagation, dead code elimination, and constant folding. There is a concept of basic blocks in compiler design. Once these basic blocks are identified, that is, we try to define basic blocks, that is, separate each of these code statements into some basic blocks. The transformations which are carried out inside these basic blocks are called as local transformations. And if we consider all the basic blocks and apply certain transformation, that transformation is considered as global transformation. Let us understand what is common sub-expression elimination. An occurrence of an expression E is called as common sub-expression. If E was previously computed and the values of variables in E have not changed since the previous computation. Let me give you all one example. We have already seen how to generate 3 address code for array references. So in this case, there is one array reference A of I, okay, wherein the code which is generated for that array reference is T1 is equal to 4 into I, T2 is equal to A of T1. Then there is one more array reference, that is B of I. So we will have to generate code for B of I as T4 is equal to 4 into I and then B of T4 wherever it is required. Now if you see this code in the set of statements which are present here, this 4 into I, if you consider statement at this point on the right hand side, we compute 4 into I and there is computation of 4 into I again at this point. And if you see, the value of I from this point till this point is not changed. Okay, so we say that this 4 into I and this 4 into I is common sub-expression. Instead of using this computation twice, that is 4 into I twice, we just write this expression once. Okay, that is T1 is equal to 4 into I, and wherever this 4 into I is required, we put this temporary, that is T1. So, okay, so if you see this last statement, T6 is equal to B of T4 is present. So we eliminate T4 because these two are common sub-expressions, and in place of T4 at this point, we write T1. Okay, so this is how common sub-expressions are eliminated. The next type of transformation is copy propagation, wherein we consider assignment statement of the form f is equal to g, or we say in short form we say copies for short. Okay, what is the idea behind using this copy propagation? Okay, the idea behind copy propagation is to use this G, okay, to use this G for F whenever possible after the copy statement F is equal to G. One simple example here, X is equal to pi is present, and there are some statements after this, and A is equal to X into R is present. Okay, so instead of having these two statements, okay, so this is copy statement F is equal to G. Make use of this G wherever required in the next statements. Okay, so instead of writing these two statements, I just propagate this copy over here, okay, in place of this X, and the resultant transformation will be A is equal to pi into R into R. So in this case, this variable X is eliminated. Okay, that is the second type of optimization technique called as copy propagation. The third optimization technique is called as dead code elimination. Okay, what is the meaning of dead code? Consider this example here. I is equal to 0 if I is equal to 1, and there is a set of code here. Now, the code which is present inside this if is called as dead code. Why? This condition will never get satisfied. Yes, okay, so if we have around 100 statements inside this if, and this condition is never satisfied in the code, okay, this value is never true. Okay, so instead of having a set of code around 100 lines of code inside this if, this full code can be eliminated. Okay, and it is called as dead code. This is one more optimization technique. One more optimization technique is constant folding, that is deducing at compile time that the value of an expression is constant and using that constant instead. Okay, it is called as constant folding. One example is A is equal to 3.14 by 2 can be replaced by A is equal to 1.57, thereby eliminating this division operation, okay, every time. Okay, so since this is a constant, we can write it A is equal to 1.57. Okay, so once the basic blocks are identified, this type of optimization techniques are applied, and there are two types of basic block optimization. One is called as structure preserving transformations, and the second one is algebraic transformations. Out of this, common sub-expression elimination we have already seen, dead code elimination we have already seen. Let's see the remaining two, that is renaming of temporary variables and interchanging of statements. So this is done. Yes. So renaming of temporary variable, say statement T is equal to B plus C, where T is temporary name. Okay, this is temporary, can be changed to U is equal to B plus C, where U is another temporary, and change all uses of this T. Wherever T is used, we can make use of this. Okay. These two statements, the next one is interchanging of two independent adjacent statements. If you consider these two statements, T1 is equal to B plus C and T2 is equal to X plus Y, these two statements can be interchanged. Why? Because these statements are independent of each other. The value computed in this expression is not required in this statement. Okay, so we can interchange the statements, or we can reorder the instructions, reorder the computations in basic block. Some of the algebraic transformation, the first one is structure preserving transformation. Some of the algebraic transformations are, say if you have X is equal to X plus 0 or X is equal to X into 1, such statements can be eliminated.